First proposed in 1895, the space elevator is one of the major avenues of research for mass space transit, getting objects and people into space. The elevator consists of a counterweight held above geostationary orbit by a space tether. A climber would traverse this tether, bringing goods to space. Carbon nanotubes, the only material strong and stiff enough to tether a weight in space, are being formed at a tiny average length of 3 centimeters. At least 35,000 kilometers is needed for company Obayashi's planned elevator. Carbon nanotubes are the only substance with a specific strength and tensile strength great enough to support itself all the way in a climb to space. Specific strength allows the cable to support its own weight. Tensile strength allows it to keep the counterweight in orbit under tension. Young's modulus is calculated by tensile stress over extension. A tiny extension for a very large stress shows carbon nanotubes to be exceptionally stiff. They are less likely to deform and stretch undesirably. Today's strongest carbon nanotubes are formed by compressing benzene. When the pressure is released, an orderly polymerization reaction forms a diamond core thread. Penn State scientist John Batting describes it as the smallest possible diamond strung into a necklace. While the cost of making a chain of diamonds that stretches into space might sound high, it is a challenge companies are willing to take. In 2005, NASA ran a $4 million competition for the longest carbon nanotubes, the Victor clocking in at 360 meters. According to ISEC, using an elevator will reduce payload costs from 15,000 pounds a kilogram to just hundreds of pounds. The future is bright for a space elevator as new materials, new climber ideas, and new breakthroughs emerge. Our earliest promise yet is by Obayashi, with 2050. Thanks.
Created using PowToons.